Welcome back to the learning session. I'm sure
Thank
all of you are able to learn comfortably in the past sessions where you should have talked about the basic principles behind Lean and Six Sigma, right? Basic principles behind Lean and Six Sigma, and should have understood the DMAC methodology, right? Define, measure, analyze, improve, and control. So, what is this DMAC methodology? A systematic way of solving problems, right? Can be a problem related to quality or problem related to productivity or problems related to delivery or cost, whatever. Can be a customer's pain point or it can be your business organization's pain point. This is what we call it as voice of customer or voice of business, right? However, whether it is a voice of customer or voice of business, we convert that into a measurable metric. Then we call it as CTQ, critical to quality characteristics. The moment you understand the metric which is actually causing the pain to the customer, the problem is considered to be defined. All of you agree with me? Till the moment you identify the metric which actually causes the pain, what you call the problem solving effort cannot start. So the first requirement is you must have a clear understanding of the problem for which you actually need the specific metric which needs to be improved. If I Because for that metric, customer will have some expectation, some target, and customer will also have a tolerable limit. That means you need to have a thorough understanding of the metric. What is the target for it? What is the upper limit up to which customer can tolerate, and what is the lower limit up to which customer can tolerate? So the upper spec and lower spec and the target. If this is understood, problem is defined, then you can proceed with creating a project charter and then get it approved by your management. The person who has the authority to approve your project, what is he called as? He is called as the project sponsor. Yes or no? So once the sponsor has approved, your project comes to live. And now then you move on to the measure phase. So what is the objective in the measure phase? Come on, you all can be interactive with me till the time I
baseline.
baseline performance. Baseline is nothing but you are now really interested in knowing the current state of the pain. Yes or no? Current state of the pain metric. Where exactly is the pain metric? You have some idea about the target and the range of operation for the metric. But where is it right now? Is it in the right interval or is it outside the interval? Do you get my point? If it is outside the preferred interval, and that is why it is causing pain to the customer. So we are interested in knowing the current state of the metric, where it is. If it is outside, we will try to bring it inside. If it is inside only, but still, something wrong, that means that the interval defined itself is, having a problem. Then you may have to redefine the interval, right? So the baseline, we are truly interested in measuring the baseline, measuring the current state of the problem. But here, while measuring the current state of the problem, you should also be uh, uh, conscious about the error that can accumulate when you are actually measuring. So we want to get an accurate estimate of the current state of the problem. I'm adding a word here. What is the word I'm adding? Accurate estimate of the current state of the problem. People might say a rejection of 5% is happening. But my doubt right now is it really 5%? It can be 5.5%, it can be 4.5%, or it can be 8% also, or it can be 2.5% also. Possibilities are there, yes or no? If if you don't have the quality information available to you, then what will happen? People will start talking approximately. Even sometimes, they will use the data in a wrong manner. Maybe some things can go wrong very easily. And sometimes the problem might get over projected, sometimes problem might get under projected, sometimes problems may not at all be present. Everything, all the problem is with the measurement only. Do you get my point? So that means the problem must be validated. Whether the problem is really, uh, a problem, right? So we need to validate the problem. So that is the objective of the measure phase. Once the problem is validated and the current state is understood, the target is also well defined in the define phase. I hope all of you also talked about the goal statement in your define phase. Yes or no? So there must be a target for your particular metric. So target is defined, current state is also understood. Now the gap between the current state and the target is the reason for the pain being experienced by your customer or your business. Yes or no? So now you must try to minimize this gap. For that, you must try to understand the root cause of the problem, root cause for the gap in performance. And we do this root cause analysis in the next phase. What is the phase after measure? Analyze.
Analysis.
Analyze. So the objective of the analyze phase is to understand the root cause of the problem or root cause of the pain. See the problem is, can be because of variation. Depending on the nature of the problem, the root cause can be variation. Root cause can be some non-value adding activities. Do you understand? If there is a time delay, if time delay is the problem which you are trying to address, on time delivery is not happening. Now, why there is too much delay? There can be some unnecessary activities happening. Yes or no? From the start till finishing. These unnecessary activities in lean, we call them as wasteful activities.
Yes.
In Japanese language, they call it muda. They call it muda. So you need to find out all the elemental activities that are happening within a process and try to figure out whether you can eliminate all of these non-value adding activities. If you can eliminate all the non-value adding activities, also try to think about the value adding activities. If someone has already eliminated all the non-value adding activities, but still you are not able to affect the on-time delivery, then you need to think about even the value adding activities. Can we redefine the way in which the value adding activities are happening? So what will happen? The same work will get completed in lesser time. Do you get my point? So this will finally minimize the overall lead time of the particular, what do you call, process, right? Overall lead time, the time between order and delivery. So ultimately, we want to reduce the waiting time, and hence the deliveries can happen on time manner. So here, what is our objective in this particular in this particular kind of project? Our objective is to find out all the sources of wasteful activities, right? Suppose if the problem is with the variation in the output, let's say you are supplying some material and the surface finish of the material is very, very important to your customer because it's a, let's say, uh, a precision component and that goes into some assembly, and surface finish is very, very important, but customer often receives products from you or items from you that has very poor surface finish. If you supply 100 pieces, maybe half of them will be good, but remaining half of them will have problem. Can you see variation here in the surface finish within the 100 units you supplied? Do you understand? Now the root cause of the problem here is variation. The root cause can be waste, root cause can be variation. Now customer sees a variation in the output. Why the variation has come in the output? Can somebody speak on this? Why there is an abnormal variation? See, a small variation, nobody is going to question. But abnormal variation, customer will immediately ask. Yes or no? Am I correct? Any customer, no, if they suddenly get very poor surface finish item, then they will immediately raise a objection. We can't tolerate this, right? And we want to cancel the order. We want to do this, that, and so many arguments will start happening. So if there is an abnormal variation in the output, can you tell me some reason why this kind of abnormalities often happens in our process?
Systemic
It
fault.
might be because of not following the
Special
process.
causes.
These are
Special causes.
special
Yeah.
causes.
Due to
Yes.
variation for
We have checked everything. We have set the production, isn't it? We have run pilot production. We tested everything. We checked our capability and everything was good. And that's why we started the production. But even
Maybe
after checking
process
everything,
variation.
yes, Balamurugan sir,
Maybe
go ahead,
process
go ahead.
variation. Yeah, maybe process variation.
There may be process variation.
Maybe
Exactly,
the
there may be
expectation
process
of the
variation.
client would be changed meanwhile.
Yes, something can change during the uh, operating the process, right? When you are actually running the process, things can change. That means
A term
you
might
are
There may be reason in the transport from the production to the customer. In the
very good.
transport also there might be some.
Okay.
the
So
variation term might shift to the left or the right.
yes, definitely correct. So that means we need to understand there can be variation within our process. There can be variation within our process. The process steps have to be carried out the way they are defined. Yes or no? All the operators should follow the procedures, SOP. But like chances are always, people can deviate. Yes or no? The machine should be in appropriate condition. Machine should have proper lubrication. Cutting tool, should have proper angle. All these things, are predefined. But in spite of that, sometimes people may not follow that, isn't it? That is also possible. And here, what we need to understand is there are factors at the input. If we control the input factors, we will not have any problem at the output. Am I correct, all of you? Very good. And now, when we come to the input factors, that is the input that goes into the process and the parameters of your own process. Out of all these parameters or all these factors, definitely some of them will be controllable and few of them will be uncontrollable. Do you understand, all of you? Some of them are controllable and few of them are uncontrollable. Say, for example, our Jaswant was saying, sir, transportation, during the transport, somebody mishandles. My product was handled badly during the transportation, during the packaging, and hence there is a problem. So now, as per we are talking at the process level, yes or no? We are talking at the process level, and there is a boundary within which we take everything good care. But transportation obviously becomes the next stage, which is beyond the scope of our project. All of you, do you understand what I'm speaking? There are certain factors which are beyond the scope of our project. But anyway, for customer, everything matters. But then, unfortunately, just one point I will not be able to address as part of my project. You know why? Because I am trying to improve a process which has only, a limited scope. Do you understand? All of you agree with me? Just by one project, you can't solve all the problem. It is impossible. You need to always know your boundary and tell your people that, yes, the problem is solved only within this boundary. Subject to these conditions, yes, the problem is solved. Okay, that is one thing. And now coming to the area, in your scope area, there are controllable factors, there are uncontrollable factors. Uncontrollable factors can also come and affect your process. Let's say your machine shop room temperature. the humidity level, and maybe to certain extent the condition of the machine, right? Overheating. So there are certain uncontrollable factor, and rarely, they can also become abnormal, and they can influence your process, and then the surface finish might get affected. So uncontrollable is one thing. And another thing is, if your people lose control over the controllables, your people can lose control over the controllables. They very well know the machine setting should be like this, but somebody might, what to say, a particular shift, they might continue with the slightly improper setting. Yes or no? So now our job is to find out which is the factor or which is the controllable factor on which we are, often losing the control. Do you understand, all of you? Because I am losing control over a particular X factor, maybe X1 or X2 or X3. My Y is getting affected. My Y is the surface finish. X may be cutting tool angle. X can be the feed rate. X can be the depth of cut. So these are terminologies related to machining process. Yes or no? People who are within the machine shop, they could easily understand. But don't worry. When you come to a real project, whatever is the relevant terminology, definitely you will be comfortable. All that you need to do, you need to understand is what are your X. So that's why it's always a good idea to have a good round of brainstorming first. You call all the people connected with the process. You call all people connected with the process. Let's say pharma industry. In pharma industry, a company is manufacturing, let's say, syrup, right? You all know it comes in a bottle. So the syrup is, a paracetamol syrup. Now, what is the requirement? What is the requirement for a paracetamol syrup? Every 10 ml of the syrup should contain 250 milligram of paracetamol. That is written. Have you noticed? Every 10 ml of the syrup will contain 250 milligram of paracetamol. And every shift they are producing thousands of syrup bottles, packing and then sending to the market. And we must definitely ensure every syrup bottle that goes out of our factory should fulfill this requirement. Yes or no? Otherwise, there are what do you call legal compliances, and then drug agencies compliances, and all these things will be there, and then it can lead to big problems. So how will you ensure every syrup bottle you produce will have exactly 250 milligram of paracetamol in it? You have to take some samples. Yes or no? Maybe every shift you will take some 5 or 10 sample bottles and then send it to your laboratory within your factory, and that laboratory will check whether every 10 ml of the syrup has the declared milligram of paracetamol. Do you get my point, all of you? Suppose all of a sudden one fine day you see that 10 ml of the syrup is having 300 milligram of paracetamol as against the 250 milligram, which is the specification. Are you able to notice a problem right now? Yes or no? There is a big problem. Something went wrong. Now you have to immediately stop the production. All of you agree with me? There is no point of continuing the production now. Otherwise, what will happen? Every syrup bottle that is getting produced will have 300 milligram of paracetamol, and it will lead to wrong dosage to the patients. Maybe kids, maybe old people, I don't know. And so the consequences can be many. So why have you decided to stop the production? Because the variation is right now abnormal, unusual. Yes or no? 250 milligram plus or minus 0.5 milligram is your capability. 250 milligram plus or minus 0.5 is your capability. But what is the reading you got right now? That is 300. 250 plus or minus 0.5 is your capability. That means upper limit is 250.5. Lower limit is 249.5. Who gave these values? Can somebody answer this? This pharma manufacturing company, they use this, and who gave this? 250.5 and
From
249.5.
formulation. From formulation.
FDA.
R&D.
Okay, FDA. FDA given means that is a customer requirement. If it is given by some kind of certifying agency or according to some guidelines, then the values must be called as specification limits. Nothing but the customer requirement. Since customer do not know, some like FDA is giving. All of you agree with me on that? There are certain areas, customer cannot speak. Unspoken requirement, but still it is a customer requirement, unspoken. So somebody else will speak about it, and then it is available as a guideline. So upper spec and lower spec are available. But with respect to the upper spec and lower spec, what is the capability of your process? Your process is designed in a way that it can operate comfortably inside the specification. Yes or no? It can operate comfortably inside the spec.
Yes.
Let me write something right now. So I'll share my whiteboard. Okay. So now the requirement is 250 milligram of paracetamol. This is the target. This is the target. And FDA says, okay, plus or minus 0.5 is okay. So this is target, mu, and this is lower spec, and this is upper spec. All of you are with me on this?
Yes.
And whenever you actually did some pilot production, you checked, because always you wanted to verify yourself before going for a mass production, isn't it? So you always see that your process operates somewhere here. Your process operates somewhere between these two. Now, according to your process, you have some limit. All of you, do you understand? These limits are nothing but control limits of your process. These limits are known as control limits. Let me say the control limit here is 250.25 and this is 249.75. All of you are able to see the control limits for your process? You are able to
Yes.
see? Yeah. See here, the control limits talks about your capability to meet a customer requirement. Right now, tell me, looking at the control limit, are you running a capable process? Customer requirement is this, but your process comfortably operates inside. Can you see that?
Yes.
That means you are running a capable process. You are running a capable process. The chance of your process producing a syrup bottle outside the specification is very, very less. Can you understand this? Because you have seen the control limit, isn't it? Your process always will operate like this. Most of the time, it will hit the target. How many of you agree with me? Most of the time, your process will hit the target. Yes or no? Because you designed it. Because you designed it to hit the target. So most of the time, it will hit. But sometimes it will fall on the right side. Sometimes it will fall on the left side. If things goes wrong, everything goes wrong, it will hit the upper control limit. Do you agree? Similarly, things can go wrong on the left side also. One of you was speaking very correctly, right? It can go right and left. So if everything goes wrong on the left side, it will hit here. Even if everything goes wrong with the process, still the product is within the specification limit. Hope all of you understand. This is the nature of the process, but unfortunately, one fine day, my sample has fallen here. What is the reading here? 300 milligram. See, normally my samples, will be within this only. But now, can you see how much distance? See this 300 milligram is not just one sample. I have taken 10 samples and I calculated the average of the 10 sample. The average itself is how much? 300 milligram. But what was your usual average? Your usual average is 250. But what is your current average? 300. Can you imagine? Can you see? Can you understand the distance here? Now your average is found outside the control limit. Am I correct with my language?
Yes.
My average is whenever I see an observation outside the control limit, I will call such observation as unusual observation. I will call such observation as unusual observation. So this is the reason why organizations use control chart. You will be learning control chart also little later. Since this observation is unusual, this is creating me a lot of doubt. Oh, something gone wrong with the process. So the production must be stopped. If production is stopped, root cause must be identified. Root cause must be identified. And before making the change, you must be very, very sure that you are making the right change. All of you agree with me on this statement? Before making some change in the process was running very smoothly last 6 months, and suddenly you being the, what you call the shift manager, you have to make adjustment in the process. Whatever change you are making should be a right change. Yes or no? Whether you are able to make the right change or not, you should never make a wrong change. Am I correct with my language again? Think about a scenario where when you are trying to solve a problem, you have invited two other brand new problem. Do you think the company will like the way you are solving a problem? Definitely no. So before making a change, you have to be very, very, very sure that you make only the right change. That means root cause must be validated before taking the action. Clear, all of you? That means root cause must be validated. See, if you call all the people and arrange a nice meeting, a brainstorming session, people will throw light on so many causes. Yes or no? Yeah, this can be the root cause, that can be the root cause. Very good. But you can't take action on everything. If you take action on everything, sometimes you might end up making a unnecessary change. Yes or no? So root cause must be validated. So normally the analysis doesn't end with your fishbone diagram. It won't end with fishbone diagram. Most of the time, most of the project, we tend to take action right after creating a fishbone diagram. But that's not the systematic way. After you create the fishbone diagram, then you have to validate the root cause. Validation is nothing but whatever people are speaking, the data should also speak the same thing. Then only it is considered to be validated. All of you understand? If people are telling, sir, this is the root cause. What is the root cause? Maybe, sir, some setting has gone wrong. Some setting has gone wrong. Or the particular temperature of the process is not correct. So, whatever the statement they make, the same communication should come from the data also. If the statement that is coming from the project team or the expert and the real-time data from the process, if both of them are conforming to the same meaning, then root cause is considered to be validated. Otherwise, if you are not able to validate the root cause, there is a bigger chance that you may end up making a wrong change, which is a major concern. Hope all of you agree with me. Yes, Vaishak, you want to ask some question?
So how to choose the right tool? How to choose whether it is a YY analysis or it is cause and effect diagram or it is brainstorming. How to choose that?
No.
Or should we
Brainstorming.
go through all three?
your brainstorming, your YB analysis, and cause and effect analysis, all of them are qualitative analysis. All of them are qualitative analysis. You discuss, and whatever points comes, you note down as it is, right? But after you perform these analysis, yes, your YY analysis, wishbone analysis, brainstorming, like Vivek sir was suggesting, you can use all of them together. Right now, what are we doing? We are brainstorming, isn't it? We are brainstorming. We are talking about a case, and then all of you are sharing your views, and I am sharing my views. So it's a brainstorming. And in between, somebody is questioning me, isn't it? So some what do you call, within the brainstorming, we are using some kind of YY analysis. And I can beautifully present our discussion in the form of a diagram, so that every person listening here can better understand our discussion. Yes or no? Instead of talking orally, if I put them in a graphical manner, some diagram, then immediately everybody can understand. That means I am creating a fishbone diagram, because people immediately understand what they see than what they hear, right? So all these three tools can be used simultaneously. The purpose is you need to list all possible root causes. What is the keyword I'm using? All possible root causes. I'll come to that. Naveen Dhoni, you want to ask some question here? I'm seeing you raising your hand.
Yes,
Yeah,
sir.
please.
You have drawn a normal distribution curve, right? So in that curve, what would be the vertical line indicate? We have a upper limit and lower limit in the x-axis, and the vertical line would represent.
Okay. Since you asked about, anyway, the normal distribution curve, bell curve, will be slowly educating all of you. But having asked the question, let me speak a little about it. See, any process, right? Any process will have a great probability of following the bell curve. Say, for example, if I collect all your age right now, do you think your age will follow a bell curve? There are 100 people here.
Yes.
Yes, it is possible. Excellent. Now, what could be the average age of the participants here?
It could be 40.
Okay. That means what? Majority of the participant here will be around the age of 40.
40 or 35, maybe. I don't. You can say in the range of 35
No
or
problem. No problem. It's only discussion sake. I agree. 40. Right. So what do you think could be the maximum age of the participant here? Maximum?
50.
Okay, 50. Whatever you say, right? And what could be the minimum age of the participant here?
40.
30. Okay. So that means majority of the participants will be around 40. That's why the curve is taller at the center. All of you, do you understand? Why the curve is taller at the center? Because too many points will cluster around the center. You are able to understand, all of you? The center is nothing but the average. Average age. Yes or no? All the age added together divided by number of participants. That is known as average age. Clear?
Yeah. Does it
Very
mean
good.
number of samples on the vertical line?
Number
Higher
of
the
sample means all the sample. Average should be calculated using all the samples, not only at the center. Everywhere there is a sample. You add all the sample and divide by number of samples. Right now in our program, there are 100 participants. So I add all 100 age and then divide by 100. I am getting this 40. That means my average age of my participant is 40. So hereafter, all our digital marketing campaign will target the audience having an age around 40 plus or minus some range. 40 plus or minus. And now I understand I could see people to the age of 50. So there is no point of targeting my advertisement to people having an age of more than 50. Yes or no? Maybe 1 or 2 people might join my program, but that's not going to serve the purpose. Clear? So the
Yeah.
maximum is helping us. These are statistics. Similarly, minimum is also helping us. What is the logic with the minimum? And the
What
people less than the age of 30, they also have a very, very lesser chance of participating in Six Sigma programs. Yes or no? So this is the range of my distribution. This is the range of my distribution.
the
The
target
range in this.
segment is not the college students.
Yes, come again, sir.
I means target the industry executives, not the college students.
Yeah, correct. Target the working professionals and not the college students. Exactly. But some bright college students might sometimes, participate. We can't outrightly reject.
Yeah,
It's a
definitely.
lesser
Business
chance.
management, engineering, gas.
Correct. So the range can be calculated using this formula, maximum minus minimum. Now, all of you tell me, what is the range according to our discussion right now? 50 minus 30, 20. Clear, all of you? Do you now understand how the age of the participant is distributed? It is distributed between 30 and 50. Speak along with me. 30 here, 50 here. If
Yeah.
I count the people who are what to say in the age group of, let's say, 32, 32, 33 or something, right? Let's say 32, 33 and 33 to 36 and 36 to 40. So this is my 33, sorry, 36. So this is, oh, I'm wrong. This is my 33 and this is my 36. Similarly, this can be 43, this can be 46. Now, if I find people who are, between 30 and 33, there will be lesser number of people. All of you agree with me? Suppose if I
Yes,
come
yes.
to this next region, 33 to 36, there can be little more higher number of participants. Yes or no?
Yes.
If I come to
Yes.
36 to
Yes.
40, now there can be, little more higher. Same pattern you will be able to see on the right side also. And the result is, what is the result? Bell curve. This will happen with respect to all biological data. Nothing but the process or the product characteristics. Nothing but the process or product characteristics. The moment you understand normal distribution, you will be able to handle any kind of data coming from any kind of industry. Can be a pharma industry, can be a manufacturing industry, can be a service industry, can be a hospital, can be a school, college, can be a bank. All that required is, it is a data which is measurable in nature. It is a data which is measurable in nature. And now one more thing I want all of you to understand is the range, whatever you calculate, no, this will be equal to 6 times standard deviation of the data. If you have sufficient amount of data, this condition is important. If you have sufficient amount of data, the range will be equal to how much? 6 times standard deviation. All of you, do you understand? If I draw a process hereafter, what will be there in the center? What will be there in the center?
Mean.
Process
Average.
average, X bar, very good. And the maximum point,
USL.
not USL, UCL, which means upper control limit.
Upper control.
The minimum point, lower
Yes.
control limit. And the distance between upper control limit and lower control limit will always be equal to 6 times standard deviation of the process. Which can also be equated to what? range. All of you, do you understand? Any process will have a spread equal to how much? 6 standard deviation. Now, do you understand why they named this methodology or approach as a Six Sigma approach?
So that it's within the range and doesn't fall outside the process.
It will see, please note, the any process will have a spread equal to 6 sigma. Whether it is falling within the range expected by the customer or not, that has to be understood now. Right now, what is that we marked? We marked the control limits of our process. We marked the control limit of our process. Now, customer will give a limit, upper specification limit. And similarly, customer will also give what? A lower specification limit. After comparing the control limit and specification limit, if your control limit is inside the spec, your process is capable. If your control limit is found outside, your process will produce defective items. All right. See, it is like, your car and a parking area. Car should be bigger or parking area should be bigger?
Parking area.
Parking area should be bigger than the size of the car.
Yes.
Your parking area is already constructed. Customer has already given the specification. Now you have to park your car within the spec. If you don't understand and end up buying a big car, you have to get your car damaged. Every time when you try to park your car, inside the parking area, because it is bigger in size, it can't go inside, yes or no? So it will definitely get scratched. So this is what we call it, the rejections, failures, and all that. So knowledge on the normal distribution will definitely be helpful. Knowledge on the normal distribution will definitely be helpful. And that is definitely required whenever your data is measurable. Whenever your data is measurable. Just a second, give me a minute. Okay. Let me stop sharing. So since one of our participants asked about the normal distribution, we spoke little about normal distribution. So what did we understand about normal distribution? The curve is, in the shape of a bell.
Center.
The shape of a bell. The central line in the curve is process average. If you also wanted to understand the bell curve of your process, what should you do? You must collect sample. Collect enough sample. Collect 100 sample. Because you need some good number of samples to visualize the complete bell curve. To visualize the complete bell curve. So 100 sample, and then you plot it in a graph, and the center line will indicate your process average. That is the point at which your process is operating. The average will always, in a perfect bell curve, the average will divide your bell curve into exactly 2 parts. Am I right? That means bell curve is symmetrical at the center. Bell curve is, have you noticed, all of you? Like if I draw a straight line at the center of my face, do you see my face symmetrical? Same manner, your bell curve will also be symmetrical. That means 50% of the curve will be on to the right side of your average, and other 50% will be to the left side of the average. Am I right?
This question here, sir.
Oh, yes, please.
Suppose the bell curve is asymmetrical,
Yes.
either on the left or right. So will this data trend be reflected similarly in the control chart also?
That means, no, there can be multiple reasons. Your samples are not sufficient, maybe. Your samples are not sufficient, but if you are very sure you have collected sufficient number of sample and there are no problem with the data, that means your process got deteriorated now. That means your process got deteriorated. There is some change transformation your process is going through. If you like that transformation, allow the process to go through. Normally, we don't like.
It may
We
be
expect the process to perform as per the what you call the original definition. So we don't like all these kind of abnormality, and so we actually take some action. This is what we call it, special cause. I'll come to that. Okay. So anyway, that's a good question. So little knowledge we gained about normal distribution. The center will divide the curve into exactly two parts. Exactly two parts. Majority of the points will be seen inside the control limit only. All of you agree with me? That means whenever your process produces an output, the output will be seen inside the control limit only. If we see an output outside the control limit, then we immediately declare that as a special cause. Then we declare that as a special cause. And everybody will start questioning, hey, why this is happening? So what I want all the participants here to understand is, there is 99.73% chance for your sample to fall inside control limit. Or in other words, 99.73% of the parts produced by your process will fall within the control limit only. How many of you understand my statement? You want me to write that number? I will write it for you. So 99.73% of the samples or parts produced, right, will fall inside the control limit. You see here, there is a control limit. There is a normal bell curve. There is an upper control limit and there is a lower control limit. So within this, what is the percentage of the parts will get produced? 99.73. That means only 0.27% of the parts can fall outside the upper control limit, and we don't want that to happen. So design your process for the 99.73% and not for the 0.27%. All of you agree with me? When you are designing a process, design your process for the 99.73% of the event and not for the 0.27% of the event. But occasionally, sometimes what will happen, our process will try to produce parts in this region. That's the time we alert ourselves and stop the production. Yes or no? So you got some idea, initial idea. Please note the normal distribution, little statistical concept. Now, first time it will be a little dry. But then once you internalize, digest, if you are familiar with the concept, then you will feel more and more comfortable, and you will also start applying these principles for making effective decisions in your project. So right now, whatever you know about normal distribution is good enough. So it's a bell curve. The center will be average, and there will be an upper control limit, which is the right extreme. Lower control limit will be the left extreme. And in order to locate the control limit, you have to move away from the center by a distance equal to 3 times standard deviation. Or other words, the control limit will be at a distance of how much? 3 standard deviation away from the center. Let me show you this also. This is your average X bar. Now your upper control limit. What will be the distance between the two? 3 sigma. Similarly, there is a lower control limit. What will be this distance? 3 sigma. And so the total distance is how much? 6 sigma. Clear? The total. So that means any process will have a spread equal to 6 sigma. Because of this concept only, the approach is named as a 6 sigma approach. All of you agree? All of you now understand why the Bill Smith and Michael Harry of Motorola named this approach as Six Sigma? Because any process will obviously have a spread equal to how much? Come on, tell me. Will have a spread how much?
Six
Six
Sigma.
Sigma.
Six Sigma.
Six Sigma. If I conduct an examination, you know how your mark will have a spread? Your mark will also have a spread equal to Six Sigma only. You will be surprised to see that. Like how I collected your age. If I measure all your height or I keep a weighing machine, I want all of you to know stand on the weighing machine. Then your weight data will also have spread equal to how much? Six Sigma. So all that you need to do is to understand, your data completely. You should be able to calculate X bar. What is X bar? Average. I'm sure you all know how to calculate average. What you need to learn is sigma. Sigma, there is a formula. You understand my formula here? What am I writing? Can one of you read out this formula? Let me check whether you know the mathematical symbols correctly. Who is going to read?
Root.
Summation of x minus x bar whole square divided 9 minus 1 root.
Excellent, fantastic.
X minus xi is a variation. X minus xi power 2 is a variance. And sigma is a standard deviation. And n minus 1 is a sigma.
Excellent. So this has been taught to all of us during 7th standard. And my appreciations to Mr. Balamurugan. Right now, you could remember everything, even till date. Now, what we all should do is, we should actually use this standard deviation in our decision making. Standard deviation is good or bad? Deviation is good or bad? It depends on the purpose, right? So variation is bad. So sigma is a measure of variation. If there is too much variation, sigma will be higher. If there is less variation, sigma will be smaller. So smaller sigma indicates higher level of consistency in the data, which means you have higher level of control over your process. Hope all of you understand, right? So, clear. So now let us go to, with this little statistical background, let us again talk about the analysis phase. Now our purpose is identify the root cause, validate the root cause, and then understand how the root cause is related to the variable of interest. The variable of interest is Y. Yes or no? The variable of interest is Y variable. This is what we call it project variable, project Y. You can also call it as response variable. Y means response variable. But now, right now in our meeting room, we are talking about X. We are talking about X. Have you discussed about Y equal to f of X last week? Y equal to f of X. Y is a function of X. We are now trying to establish that equation. If you are able to write down that equation correctly, that means you have understood the root cause, you understood your process, you have understood your response variable, you have understood your root causes, and you also have understood the relationship of the root cause with your response variable. So we are actually trying to identify the root cause, validate the root cause, and we are also trying to understand how much effect is coming from each of the root cause. All these questions are important, yes or no? First, you should have an idea about the root cause. It can be just one root cause affecting the whole process, or it can be a group of root causes affecting my process. The crime should have been done by a single criminal. There can be multiple criminals also. Single root cause, multiple root cause. If there are multiple root cause, how much effect or how much problem, how much deterioration in Y is contributed by each X? Correct? So, accordingly, we need to take action. Accordingly, we need to take the action. So, before going to the root cause, first what you need to identify is possible root causes you need to list down. And the tools that can help you to list the possible root causes are nothing but brainstorming, Y-way analysis, fishbone analysis. That you already discussed. So that is the first step in analysis. So the outcome is possible root causes. Tell me, in a big hall of 200 people, it's a function hall. There are 200 people, and all the valuables that are kept in a particular room was found to be stolen. Now tell me, how will you identify the culprit now? Where will you search for the culprit? Who can be the culprit now?
All the 500.
All the people present in the hall. Yes or no? I said 200 people.
Not 500.
All these 200 people, if you make a list of all the 200 people, the list is known as possible root causes. The list is known as possible root causes. If you don't take this action quickly, if you don't note down the names of all the people, don't collect the information about all the people, you know what they tend to do? The moment you understand, you are analyzing, somebody will escape through the back door. Yes or no? So, the first step towards recovering a loss is identifying possible root causes. But since the number of possible root causes are 200, it is practically impossible for anybody to perform a thorough investigation with each of the person in the hall. Yes or no? So
Yes.
you will start applying your common sense. You will categorize the 200 people into some group. Tell me what are all the groups you will divide them. Some of them are your relatives. Yes or no?
Like people who are closely moving towards the lot.
Correct. So some of them are your friends. Some of them are your relatives. Within the relatives, some of them are your close relatives. Some of them are no long relatives. Some of your friends are very close friends. And out of those, few of them were given access to that room. Can you see your all 200 people getting grouped into different categories? Are you able to notice here? I am dividing the 200 people into 5 categories. Friends, relatives, close friends, and close relatives. And finally, one set of people who are given access to the room. How many categories? 5 categories. I am not using 5M here. Can you see that? It is not required for me right now. Isn't it? In my hall, no, I kept 10 lakhs worth of some valuables. The money matters a lot. So I will think wisely, yes or no? You should also think wisely during your analysis. It is not always 5M or 6M which can help you. Sometimes you have to find out your own terminology. Clear? Very good. And now that you grouped, over and above the grouping, you will certainly go through the CCTV footage. Yes or no? Some information will definitely be available. This is called, the first-hand information, like police call it, FIR. Right? Same manner, we also refer to the available data. We ask people opinion and all that, with the help of all of those, I will narrow down the list of 200 into a list of 10 or 12 or 10 or 20, no problem. Do you understand now? There were 200 people. Now the list is narrowed down to what? Just 20. All remaining 180 people can now leave the hall. We are going to continue the investigation only with 20 people. These 20 people probably if you involve the specialists, experts, police, they will take these 20 people to the police station for the next level of investigation. Yes or no? Now these 20 people are known as potential root causes. Clear all of you? Earlier 200. What is the name given? Possible root causes. Or sometimes you can call it as probable root causes. But now, what is the name changed now? We only have a small list of 20 people. What is the name given now? Potential root causes. Within this 20 only, we have the culprit. Maybe one, maybe two, maybe three. We don't know. It can be a group or it can be just one person. Yes or no? All right. So how can you now do the same work in your project? How can you reduce 200 to 20? Do you want to involve some experts? Take their opinion, isn't it?
Pareto
Take their opinion.
analysis.
Pareto analysis, yes, do the Pareto analysis, 80-20 rule, Pareto analysis. Somehow you have to know, assign some ranking. Every factor you give some ranking, some kind of numbering. And whichever factor that gets more score, that means the suspect is more. Do you understand? That means the suspect is more. And so those factors should be taken to the next level. They are known as potential root causes. You can think of using an impact control matrix. See, the templates are available, some formats are available using which, your job will become much easier when you actually work on, real project. And see here, I'm just drawing a rectangle here. And this is impact and this is control. 2x2 matrix. And now this area is high impact, high control area. What is this quadrant? High impact, high control quadrant. And this is high impact, but low control. And what is this area? Low impact, low control. And this area will be low impact, but high control. All of you, do you understand the meaning of H and L I have written here? There are 4 quadrants. Every factor, you must try to understand whether it falls into your, this first quadrant or second quadrant or third quadrant or fourth quadrant. This is one method. And whatever factors that falls in the fourth quadrant, that should be called as potential root causes. This is one method. And in order to place a factor in one of these quadrant, you have to have a proper understanding. What is the process we are analyzing? What is the what is actually our y variable? What are the x variable? What is the particular x variable we are talking about? What is the current condition of the x variable? Everything you need to understand and take the people's opinion, and based on the opinion, even experts' opinion, and as well as people's opinion, your whoever connected to the process, with all their opinion, you can categorize. And everything that appears here in the high impact, high control region can be considered as the potential root causes. All the potential root causes will qualify for the next step known as validation. What is this? Validation, root cause validation. Root cause validation procedure, which is a statistical procedure which will be taught little later, which is a statistical procedure which will be taught little later. Next week we will be discussing with all of you. So the tool name I will write here. The tool is nothing but hypothesis testing. Do you understand, all of you? What is the tool that can help you to validate the root causes? Hypothesis testing. Right now, we are going to take it granted. We are going to take it granted. That means root cause is validated. Let us say you have x1, x2, x3. 3 factors. three root causes are validated. X1, X2, X3. Now I have to take action on X1. I have to take action on X2 as well as on X3. All right, X1, X2, X3. Let me erase all of this. I'm erasing. So now my Y is affected by how many root causes? Tell me, all of you. How many root causes according to our discussion?
X1, X2, X3.
3. So my Y is currently a function of X1, X2, X3 only. Now, right now, my Y is currently a function of X1, X2, X3. Only the X1, X2, X3 are in poor control. All of you agree with me? My X1, X2, X3 are in poor control. That is why my Y is getting affected. Agree, all of you? We are going to tighten our control over X1, X2, X3. If somehow, if you can tighten your control over X1, X2, X3, that is nothing but the solution. Yes or no? Okay. Now, other than X1, X2, X3, there are so many factors. All of them are in good control. All of them are in good control. The factors which are under very good control are no more variables. You understand? The factors which are under very good control, they need not be called as variables. They will be constants. Yes or no in mathematics? So I add a constant. What this constant represents? The
No
effect.
variation.
The
No
effect
effect.
that may come from the other factors. I have no problem with the effect coming from other factors, but I am not satisfied with the effect coming from X1, X2, X3. All of you understand what I'm speaking? Is that clear to all of you? I am actually trying to break down the statistics. In the
Yes, sir.
process, it should not get complicated. All right? So keep informing me whether you are understanding or not. Okay. So I take it granted. You have understood, right? So now we are interested in understanding everything about X1, X2, X3. Because we are not bothered about X4, X5, X6. Because all of them finally leads to what? C, constant. That constant effect, let it continue. But the effect that is coming from the X1, X2, X3, that is what I don't like. That is finally affecting my bigger Y. So now I want to understand how my X1 is connected to Y. How my X2 is connected to Y. How my X3 is connected to Y. Do you all of you understand what you need to actually understand to offer a proper solution? Let us say Y is boiler efficiency. Y is boiler efficiency. Y is boiler efficiency. And X1 is the operating temperature of the boiler. Now you found that the operating temperature of the boiler is incorrect. Now you realize the operating temperature of the boiler is incorrect, or operating temperature is responsible for the poor efficiency of the boiler. Now you have to correct the operating temperature. Now what is the factor? Our factor is operating temperature. Now for this factor, you must first understand range of investigation. You must understand range of investigation. Now, if you have a boiler in your workshop, in your workplace, will there be any indication about the operating range of the boiler? Yes or no?
Yes.
Let us say the operating range of the boiler is 700 to 1000 degrees Celsius. Currently, your boiler is operating at a temperature anywhere between 700 and 1000. Can you understand the range of operation of the boiler here? All of you, do you understand? The range seems to be higher side. Can you understand here? The range is quite higher. Lot of flexibility given for a particular X. Everybody in the company believed that 700 to 1000 is a, throughout the range, it is good for the boiler efficiency. That is the current belief. Yes or no? But actually, that is not correct. Actually, that is not correct. Why am I saying? Because it is based on the analysis, it is found that so far our company believed that we can run the boiler anywhere between 700 to 1000 because it is written in the boiler itself. It is written in the boiler instrument itself. Operating range is 700 to 1000. So you allow it to operate. But now suddenly you realize the operating range is bad. And that is pulling my boiler efficiency down. So you have to find out a new range. The range can be sometimes, in certain scenario, you may have to find out a new range completely outside the current range. Or if that is not possible, you may have between 700 and 1000. This is 700. This is 1000. Maybe a particular range within 700 to 1000. Let's say this is 800 to 900. This range is good for the boiler efficiency. So what you need to do is you have to reduce the operating range of your boiler from 700 to 1000 to 800 to 900. Now what is this? This is known as, so optimizing your X is known as the solution. All of you are with me on this, whatever I'm talking? But how will you know 800 to 900 is the good range for your boiler? So for that, what you need to do is you must actually study the relationship. Study the relationship between your boiler temperature and boiler efficiency. You have to study the relationship between boiler temperature and boiler efficiency. Boiler efficiency is Y variable. Boiler temperature is X variable. All of you understand what is Y here? The boiler efficiency. What is X here? The temperature of the boiler. What is the current range? 700 to 1000. Can anybody help me? How can I study the relationship right now? How can I study the relationship?
Correlation.
Very good. Correlation, scatter analysis. That is what I'm trying to do. Before correlation, perform scatter analysis. Scatter plot. Scatter plot is one of the 7 basic QC tool you can use to study relationship between X and Y whenever both of them are measurable. Whenever both of them are measurable. X should also be measurable. Y should also be measurable. Temperature is measurable. Efficiency also measurable. Clear, all of you? Now what I want is, I want you to run the boiler at the 700 degrees Celsius. And the boiler at 700 degrees Celsius. Run it 2 times, 3 times. Try to understand the efficiency. The efficiency is found to be between 60 to 90. 60% to 90%. The efficiency is found to be between 60 to 90. Somewhere here will be, let's say, 75 or something. So whenever I run the boiler at 700 degrees Celsius, the efficiency is found to be around 60%. How did I know that? I have run the boiler 3 times, 5 times, keeping the temperature purposely at 700 degrees Celsius. All the times, what is the efficiency I got? 60%, 61%, 59%. And so the average is how much? 60%. All of it, do you understand? How did I got the point? Now I run the boiler at the middle value. Middle value is 850. Or before coming to the middle value, come to the 1000. Run the boiler at 1000. If I run the boiler at 1000, I am getting always my boiler efficiency is here. Not just one time. I am running it 2 times, 3 times, 5 times. Always my readings are around 85, 90. Now, what do you understand? When I increase the boiler temperature, what happens to the efficiency?
Increasing.
What happened to the efficiency?
Increasing.
Increases. So the relationship is found to be positive. The relationship is found to be positive. Now, what do you want to achieve? You want to achieve boiler efficiency. You want the boiler efficiency to go up or come down?
Go up.
It has to go up. You want to maximize your Y. And now, with the help of the scatter diagram, you are able to understand how a particular X is connected to Y. This X is connected to Y positively. So, right now, definitely the idea will strike to your mind. What should you do now? Increase the operating temperature of the boiler. Yes or no? If I increase the operating temperature of the boiler, it can lead to better efficiency of the boiler. That is quite obvious by plotting a set of data in a graphical format. And this analysis is known as what? Scatter analysis. The graph is known as scatter plot. I have plotted two things. I also want you to think about the center point. Between 700 and 1000, please note this 700 is an end point, 1000 is also an end point, but 850 is a center point. At 850, you conduct 2-3 experiment and try to understand what is the efficiency of the boiler. Suppose if the efficiency is found somewhere around 75. Can you see all the points forming a linear pattern? That means the relationship is positive as well as linear. The relationship is positive as well as linear. That means the relationship is static. As X keeps on increasing, Y also keeps on increasing at the same rate. Do you understand? As X increases, my Y also increases. The trend is positive throughout the investigation. Can you see that? Throughout the investigation, it is positive and it is stable. This is known as linear positive relationship. This is known as linear positive relationship. Moreover, if you look at my points, all of them lie on a perfect straight line. Can you see that? So you can add another word in front of the linear. This is perfect positive linear relationship. All of you are with me on this? Perfect positive linear relationship. In this condition, if you calculate correlation coefficient, that correlation coefficient will be exactly 1. You don't have to calculate. If you know how to use the scatter plot, you no need to calculate correlation coefficient. But sometimes points may not be always like this, in a perfect manner, it won't come. So to understand better, the coefficient is introduced. How the coefficient is introduced? Whenever it is a perfect relationship, what will be the value of R? 1. Clear, all of you?
Yeah.
The R is known as correlation coefficient. The R is known as correlation coefficient. Okay. Let me give you another scenario for the same problem. Your Y and X. 60 efficiency, 90 efficiency. Now, I keep on increasing the temperature from 700 to 1000. Now, my efficiency is, when I keep on increasing my temperature, the efficiency is also keep on increasing. But after some point of time, the efficiency started coming down. This is also possible, yes or no?
Yes.
Now my relationship is positively increasing up to a point, and after that it is negative. Now I cannot call the relationship as positive or negative. Sometimes positive, up to a particular point it is positive, afterwards it is negative. That means the relationship is dynamic. Can you see that, all of you? This is what we call it as non-linear relationship. This is what we call it as non-linear relationship. Earlier, in the case of static relationship, you wanted to increase the operating temperature. In earlier scenario, when did you got a higher efficiency? When the operating temperature is around 1000. Do you remember? All of you, do you remember when I drawn the graph here?
Yes, yes.
When I increase the temperature from 700 to 1000, you continuously noticed efficiency going up. So if at that condition, if I ask you to choose an optimal range, let me show it again, no problem. So this is like this, 700, this is 1000. And here the efficiency is 60, here it is 90. Now which efficiency you want? You want 90. Now you choose a range here. Now the range is 950 to 1000. All of you, do you understand? What is the selected range? That means the target is 975. And for the operators to have some tolerance, I have given plus or minus 25. All of you understand the new operating range for the boiler? In the new operating range, the efficiency is always between what? 85 to 90, which is quite satisfactory. Clear, all of you? So if you properly analyze a data, the solution will evolve automatically. Am I right? If you properly analyze the data, the solution will evolve from your analysis itself. How many of you understand? Right?
Yes.
Data itself is allowing you to think in the right direction. Now let us think about the nonlinear relationship. Now tell me, all of you, where is your efficiency getting maximized?
Center.
So here it is 850. Again, you have to give some tolerance.
Plus
Now
minus
850 plus or minus 2. This plus or minus 25, out of experience, you can decide. Right? So now for linear relationship, the solution is 975 plus or minus 25. But for non-linear relationship, the solution is 850 plus or minus 25. In both cases, it is boiler. In both cases, it is boiler. But one boiler is behaving in a linear manner, the other boiler is behaving in a non-linear manner. How your boiler is responding to the temperature. One boiler is responding to the temperature in a linear fashion, but another boiler is responding to temperature in a non-linear fashion. Yes or no? Do you think this piece of information is required for you to generate the solution? Tell me, all of you. Is it required, really required?
Yes.
Because if this information is not available, you will be generating a solution using an approach known as trial and error approach. It may work, it may not work. But here, it is very evident with some experimental data, yes or no?
Yes.
We performed the experiment, and every experiment, I wanted you to do it 2 times, 3 times, 5 times. You know why? Your decision should not be affected by experimental error, yes or no? So I wanted you to repeat your experiment 2, 3 times. If you this is known as replication. If you replicate your experiment, the experimental error will get minimized. And so your decision can be more and more effective. So the purpose of scatter analysis is to study the relationship between an X variable and a Y variable. Relationship can be positive, relationship can be negative. Relationship can be linear, relationship can be non-linear. Clear, all of you? All that required is a set of experimental data for X and Y. Please, all of you, please understand, when you are studying the relationship between X and Y, you have to run the process in the same condition to the extent possible. Do you understand my statement? You have to run the process in the same boiler only. You should conduct the experiment. Yes or no? You can't go to a new boiler and perform the experiment. There is no use. Your process is happening in a 10 years old boiler. So your experiment should also happen where?
Same.
In the same boiler only. You can't perform experiment somewhere outside. So make sure you conduct the experiment in the process in the same condition. But only one limitation you will have right now is you have 3 root causes. But now the limitation is you can study only one factor at a time. The scatter plot, the limitation is you can study only one factor at a time. After studying X1, but nothing wrong. After studying X1, you can study X2. After studying X2, you can study X3. So you will have three scatter plot, which will clearly tell you what kind of relationship exists between your X and Y. Clear, all of you? Any question you want to ask?
Yeah, sir, I have one question.
Please.
Sir, in this same scenario, uh, uh, I have a question like, if I have 4 injection molding machines and I have defects are coming, means the mold is not fixed in particular machine, then how can I define the root cause maybe for the
Okay.
defects coming? Which machine I cannot easily identify?
So from Jaswant, what I understand is he has got 4 injection molding machine. Is that correct?
Yes.
And his doubt is on the machine itself. His doubt is on the machine itself. Am I right?
Yeah, means I am.
That means the factor under suspect is the machine is the factor. The X variable is machine. Can you understand? The X variable is machine. The Y variable, what is Y variable? What is your Y, Jaswant? Your Y is?
The defects coming.
Defects, okay. So he doubt that one particular machine out of the 4 is producing all the defects. So what Jaswant has to do is, Jaswant has to study the defect rate coming from each machine. Machine 1, what is the defect rate? Machine 2, what is the defect rate? Machine 3, machine 4. There are 4 machines he is trying to compare at a time. Please note, now the X factor for Jaswant is not measurable. Because what is his X factor? It is only machine, isn't it? You can only differentiate the machine. You can't measure. Measurable characteristics, you plot a scatter plot. But it is a non-measurable characteristics. Machine number 1, machine number 2, machine number 3, machine number 4. Now he can only compare. Now he can only compare. Comparing 2 or more number of groups for a particular outcome is known as a study called as hypothesis testing. I have not taught you the hypothesis testing as part of today's session. Yes or no? So Jaswant will be able to better handle the scenario after learning the tool known as hypothesis testing. Jaswant, but right now the clue now is you need to perform hypothesis testing. After completing hypothesis testing, you will be able to conclude whether machine is the reason for the defect or not. If machine is the reason for the defect, then whichever machine that gives a higher rejection, that machine requires some additional attention. Maybe you have to recondition the machine or you have to scrap and then buy a new machine. Clear?
Yes.
So
Sir.
that is hypothesis testing, but we have gone one step ahead of hypothesis testing. You know what is that? We started studying the relationship, positive, negative, linear, non-linear. That information will be helpful to understand, to generate the solution. So can I have all your attention for another 5 to 8 minutes? 10:30 will close. Is that okay?
Okay.
Yeah. Yes, Mr. Satyendra. Yes, sir.
Injection molding case, 4 machines. So data collection also will be important, sir, and classification. Will stratification help?
Yeah. See, stratification is very, very important, right? Always we have to slowly deep dive so that we peel away the symptoms and reach to the causes. That's very, very important. Stratification is always important. You must get into the depth of the, what you call, the details always. And, just one's point is, he wanted to figure out whether any difference exists within the machine. There are 4 machines. Is there any particular machine producing
Means,
unusually higher number of defects?
sir, I was like, how to improve the process? Means I have in my plant there are 10 different machines in Dermo, Duro, everything.
Hmm.
So that as the example you were giving about one boiler, so I was a little confused how to attain process efficiency for the whole process as such.
No. See, we are studying one characteristics of the boiler, one expector.
Okay.
Temperature we are studying separately, but after finishing the temperature, your next expector, we see how many number of potential root causes. It can be the boiler operating temperature. It can be the fluid flow rate,
Yes.
right? Whatever liquid that is flowing inside, its flow rate and the pressure, whatever. So one by one, we have to study. So that is also the limitation also. In scatter plot, we need to study the factors one by one. But the reality is, if you want to better understand, you need to study all the factors simultaneously.
Exactly. Yeah.
If you study all the factors simultaneously, the study is known as design of experiments, which we will be
Yeah.
teaching you third week, further, higher weeks,
Okay. Okay.
right? Because straight away, if we talk about all the statistics, it can be a bouncer to many of you.
Hmm.
I want to see all of you, playing comfortably, right? So you understood some knowledge about bell curve,
Yes.
and you also understood, the scatter plot. Now, see, finally, when it comes to the real work, real time project, things are much easier, not like the theory, isn't it? Because now some tools are available. Your Excel can plot your Pareto, yes or no?
Yes.
Nowadays, nobody is plotting, graphs manually. They use Excel, they use softwares like Minitab. Suppose scatter plot you want to plot, you don't have to plot manually. All that required is you collect the data and feed it in the Excel. And then the graph will be, created. You take a decision properly. That is very, very important.
Yep.
So now what I will do is I will open my Excel, and then show you some data. And then I will also show you how easy it is for you to use some tools and then, complete your analysis. So I share my complete screen. You should be able to see my complete screen. Now there is an Excel file. Now what I want is, I want to these data files I will be sharing you little later. So I'm searching the sheets because there is at some area, there should be a file named hydrogen content. All of you, can you see my file name hydrogen content and porosity?
Yes.
So in which industry you can hear these kind of words?
Petrochemical.
Okay. petrochemical or some aluminum metal casting industries, isn't it? So porosity means there are some holes in your product. It's a solid product, but some holes are found on the inner surface. That is known as porosity. And the brainstorming discussion happened, YY analysis happened, experts have come to the place, and they were telling that hydrogen content is the culprit. Why there are some pores? Why there are some holes? Because gases are getting trapped within your molten metal. In casting means they melt the metal and then pour it into a die. And then during the solidification process, if some gases are also part of your molten metal, then what will happen? Some holes will get formed inside the solid. Yes or no? So experts are telling the hydrogen content that is present in your raw material could be the culprit. So hydrogen content should not be above the permissible level or whatever. So because based on this suspect, people have done some analysis. All some 20 porous casting they have taken, and then the porosity is measured. Similarly, the hydrogen content is also measured. And now I want to study whether hydrogen content could be the reason for porosity. So what should I do? I should actually plot a scatter diagram. So you can plot it in Excel also. Excel also uh, should be having, but I will show Excel as well as Minitab. In Excel, let us try um, insert recommended charts, and then yeah, straight away it is showing some scatter. Oh, great. This graph it is recommending. So I just click this. Can you see here a graph, all of you?
Yes.
And now actually the unwanted area and all you need to cut down in Excel. This is the problem. So what I do is I'll take you to a better software, which is highly customized for the Six Sigma analysis. The software name is Minitab, and slowly you can learn to use any one such software. All of you, can you see my Minitab screen right now? All of you,
Yes.
please confirm. Are you seeing my Minitab screen?
Yes.
Yes.
Yeah. The area where I am actually moving my cursor, this area is known as worksheet. It is similar to your Excel. Here you can actually copy paste any data. I want to paste something here. So let me move to an empty area. Yes. I am just pasting the copied data. Control C, Control V. All of you, do you understand how did I got the data here? From the Excel, I copied and then pasted here. And this area, white color area here, this area is known as session window. In this window, you get your statistical reports. But now my purpose is to plot a scatter plot. So go to graph. Can you see scatter plot? The first one, graph scatter plot. There is a description available. Examine the relationship between a y variable and the x variable. And scatter plot can work well and preferred only when x and y both are measurable. So click this. Now there are simple scatter plot. Choose the simple one. Now Minitab is asking you which is your y variable and which is your x variable. My y variable is porosity. I click and select. My x variable is hydrogen content. I click and select. And now I give OK. It gives me a scatter plot much better than the scatter plot we have seen using Excel. Can you see here, all of you? And looking at the scatter plot, what do you understand? As the hydrogen content keeps on increasing, can you see the porosity slightly continuously going up? Can you see a positive trend? Yes or no? But this is not a perfect linear. We are not able to see a perfect linear, isn't it? The relationship is not perfect. It is only moderate. The relationship is only moderate. Sometimes, there may not be any relationship at all. So let me also show you. Now see here, the situation is doubtful. Can you understand, all of you? That is why correlation coefficient is introduced. You remember I told you for perfect linear relationship, what is the R value?
1.
1. But right now you will not get 1. So let us calculate correlation coefficient so that we can better comment about this. So go to stat. Again, now earlier I clicked graph. Now I want you to click stat, basic stat, correlation. Click here. Now this window will come. Here you just have to select the two variables of interest. Select both of them. Now you give OK. Now the Pearson correlation coefficient has come. Well, how much is the value? Pearson correlation coefficient value? Tell me.
0.625.
0.625. 1 means perfect. Any value, I'll tell you, any value from 0 to 0.4. 0 to 0.4 means weak correlation. Means weak correlation. And 0.4 to 0.7. 0.4 to 0.7 is moderate. And 0.7 to 1 is, we call it strong. But exactly equal to 1 means perfect. Equal to 0 means no correlation. All of you understand the conditions? All of you understand? 0 to 0.4 is weak correlation. 0.4 to 0.7 is moderate. 0.7 to 1 is strong. Exactly 1 means perfect. Exactly 0 means no correlation. Now tell me 0.625. What kind of correlation we have?
Moderate.
Moderate. We have moderate correlation. So now let us find out something known as R square. R square means R into R. 0.625 multiplied by 0.625. Can somebody help me with the answer? 0.625 multiplied by 0.625. Tell me how much it is. Am I correct?
0.390.
0.39. That means the effect that is coming from the hydrogen content is 39% only. Do you understand the message here? The porosity problem can come from multiple factors, yes or no?
Yes.
And 39, if there are multiple factors, then the effect will be, contribution will be shared equally or unequally. Now we studied first factor. What is the contribution of this factor? 39%. That means remaining 61% of the reason is still not understood. Yes or no? I know how it is difficult for all of you to understand statistics after 10 o'clock, but still.
I have to study X2 and X3.
Yeah, we may have to study X2 and X3. And definitely the analysis right now is demanding us to do more analysis, further analysis. Yes or no? You can't
Yes.
conclude your root cause analysis at this stage because you have understood only 39% of the root of the problem. Still 61% you have not understood.
Yeah.
If you think that this is the only root cause and close the project, then the same problem, will again repeat. That means you have not, somewhere you have made a mistake. You have not identified all the root causes. In your fishbone diagram, you have not included some factors. or you have not identified the potential root causes properly. If you, for some reason, if you are, not, if your team member don't participate properly, don't develop the fishbone diagram properly, don't shortlist the possible causes to potential cause properly, then you will get a very poor R value here. Do you understand, all of you? Very poor R value and hence very poor R square value. Actually, you all have to calculate the R square after studying all the factors. Now I have told you only for one factor. You have to calculate the R square by studying all the factors. But that approach is slightly different. That study is known as design of experiments. That will give a more clear picture. But right now, anyway, we got some good understanding here. Definitely, please note, definitely hydrogen content is a critical to porosity. That is no doubt. Hydrogen content is critical to porosity because how much effect is coming from hydrogen content? 39%. 39% is a significant effect. Yes or no? For example, in your family, if you want to make some decision, your decision will definitely be influenced by the family members. Am I correct? Who are the family members? Your spouse, your children's, your parents. Whose influence will be more on your decision? Whose influence will be more?
Tricky question.
Spouse influence will be more. 80% influence comes from your spouse. And another 20% influence comes from
Family.
your children. And no influence from parents. Nowadays, nobody is listening to the parents. And so, influence is very less. So that percentage we are trying to understand here. Can you see that, all of you? The hydrogen content, how much influence it is? 39. That means still few other factors are equally critical, maybe more critical, that you have to study and then proceed to the solution phase, which is improve phase. Till you get an R square of minimum 80%, you're not allowed to move on to the next phase, which is improve phase. Your analysis is considered to be completed only when you are able to get an R square value of minimum 80%. Clear, all of you? How we used the scatter plot and the R value. Using R value and R square value is known as correlation analysis, and the name of the R square is called as coefficient of determination. So be familiar with certain terminologies I am using here. So that will be highly helpful when we talk at the next stage. R means Pearson correlation coefficient. R square means coefficient of determination. We want the coefficient of determination to be 80% and above so that you can conclude the analysis, and with the knowledge gained, you can move on to the next stage, which is known as improve. You can call all your people, have another brainstorming session, another brainstorming discussion. With all this information, your brainstorming session outcome can be a beautiful solution. Clear, all of you?
Yes.
So this is what I wanted to discuss with all of you. Thank you very much for giving me enough time. Like, I exceeded my timeline of 10:15. I hope still you people could, adjust and then listen everything properly. If there are any questions I would like to ask, I would like to answer, or otherwise, I'm done with the day. And if you want to leave, also feel free to leave, because I don't want to hold you for a longer time. But any questions? Yes, I want to be available and then I can answer your questions.
Okay, thank you, sir.
The most critical thing that how we deploy these things in project.
So the point is, you should be very, very good at breaking down the complexity. And till the time you break down the complexity, you will not be able to think properly. Do you understand what I'm telling? I think one of you, Satyendra, was talking about stratification. What is stratification? You have to specifically understand the problem. If I simply say problem is, very, very generic. What is exactly the problem? Which product you see a problem? First question. Yes or no? And within that product, what is your exact problem? There can be 10 types of problem that can happen with the product. Out of the 10, what is the one you want to solve? What type of defect you want to fix? And then for that particular defect, come to the process level. What is the process that is actually triggering the failure? Whether you want to correct all the process or you want to correct only a particular process. Like you remember during our discussion, our Jaswant was saying, sir, during transportation also problem can happen. But I don't want to attend to the problem, transportation issue. Because I am responsible for the process that is happening within my factory. So my scope is limited to that process only. So this thinking, breaking down the complexity and knowing your process boundaries is very, very important for an effective thinking and problem solving. Otherwise, you will not be able to think properly. If you can't think properly, you can't act properly. Try to be as specific as possible. Have I answered your question? Maybe with some examples,
Yes.
some project example, you will be able to better understand. I strongly encourage each one of you to continue your learning journey with us. You can't conclude anything, just by attending 3 days, 4 days training program. Pick up a project also. Try to pick up a project from your current workplace or wherever it is possible, and then continue your learning with the mentors here. That's why, you already met Vivek Kumar, and I have joined now. And again, in the 5th week onwards, and few other faculty members from our side will come and join. So all of us can certainly help you. To one of us, you can reach to and then continue learning from us. Is there anything else I can help you with? How was the session otherwise?
Thank
Sir,
you,
in
sir.
other sir, in other words, we can say
Mhm. Yes, somebody is trying to teach something new. You are sharing a screen. Yeah, please. Yeah, yes. Otherwise,
so in other words we can
chief.
say if in the PFMA RPN number is high, then we can reflect at the potential effect and then concentrate in that cause and
Okay.
then we
So Jaswant is jumping to another tool which is known as FMEA, failure mode and effect analysis. Failure mode and effect analysis. And see, FMEA is a tool for solving the problems proactively. But right now we are talking about solving problems reactively. Some problem has happened. Now I am investigating for the root cause. This is proactive approach or reactive approach.
reactive.
But FMEA should be used as a proactive tool.
Yeah.
But in some situation, some industries use FMEA also as a reactive tool, right? But FMEA is slightly a different approach. Finally, all of them, are trying to fix the problem. Please understand. Finally, we want to deliver defect-free products to our customer, right? All the approaches, finally focus on customer satisfaction. So FMEA is slightly different approach. We will definitely talk about FMEA also. But right now we are discussing in terms of the process. Okay, I believe you are able to follow me, even though I spoke little statistics today. But please note, without learning statistics, you can't go out and say you are a Six Sigma belt.
Yes.
In many places, many scenarios, people end up simply getting a certificate that will not serve the purpose. You should feel highly comfortable with the data while dealing. No, you should be able to deal with the data. That means you should slowly become a statistician also. You should be able to use data, understand the data, what data is telling. and what people are telling. Are they matching? If they are matching, your decision, can be more and more effective. Whatever decision you take, that will be, the right one. The chances of your decision going wrong will be lesser. And slowly, I want to turn all of you into wonderful researchers. You can't solve, problems, just like that in one step. Definitely, when the problem becomes more and more complex, then steps will also become little more complex. But we will break down all the complexities. We'll break down all the complexities. So what you need to do is you must try to internalize the learnings one by one. Whatever terminologies you are learning newly, you should be able to practice. Try to write down some new notes on your own and then refer to the notes on a daily basis throughout the course. Don't just depend on your exactly the training hours. Training hours are meant for the live interaction with the trainers, but your learning should happen even outside the training hours. All of you agree with me?
Yes.
Yes or no?
Yes, sir.
Yes,
Thank you.
definitely yes.
Yes, yes.
Then only you will turn out to be, an outstanding Six Sigma belts. Otherwise, again, you will will be an average belt in the market, and nobody likes average. Everybody wants, the best. So some hard work is certainly required. So be prepared for that, and we will certainly, stand with you and then help you learn everything to your satisfaction. But there has to be a lot of curiosity, a lot of questions. I really loved the way you all interacted. A lot of questions you answered, you all raised. So that will simplify our job. If there are no questions, we will be confused whether we should teach further or not. Okay, thank you very much. Good night. And we'll be meeting again tomorrow. And please note, we are finishing our first round of learning with respect to DMAC. Once the first cycle of learning gets over, we'll go to the second round of learning. And during the second round of learning, you are expected to know the first level of learning. Right? So first week, whatever you study, you should be able to refresh, come with some basic idea during the second round of learning. And after finishing the second round of learning, we will be having the third round of learning. Slowly, we will be introducing you some advanced, concepts and advanced tools. And finally, you realize all of them are very, very simple. Okay?
We must.
Yes, sir.
Before we enter the second phase, toll gate review is a must.
Yeah, we will be having. Yes, definitely. Okay, thank you very much. Bye-bye, good night. And then we'll be meeting tomorrow again, same time. Good night.
Thank you, sir. Bye.
Most welcome.